heart going on right there. I wear my sunglasses at night. Today we're talking about 23.4 congruent figures. This is going to be a little bit tough. The good news is it's mostly multiple choice. So let's take a look at what we got here on the key concept, a little about 10-15 second video clip here on exactly what we're talking about when we talk about two-dimensional figures being congruent to each other. It means they're the same shape, same size, and they're talking about mapping them to each other. Here is the symbol you're going to need to be aware of. That symbol right there, an equal sign with basically a piece of lasagna on top of it. Looks like it basically means congruent to. So here we go. Let's let this cat talk quick. All right, so you saw that in action, and you could see that basically what they did was first of all, they did two different things there, and so that's what you're going to need to be paying attention to. Is there's going to be multiple, probably a couple steps in terms of what's going to happen. Now, again, this first one is pretty easy because what you're going to see, and I don't know why they separate these two things, but they are going to. They're going to take triangle ABC, and they want to tell you that it's congruent to triangle A prime, B prime, C prime, and they want you to describe it as a series or a sequence of rigid motions. Now again, they're going to give you two methods. One method is the one that you're used to seeing in the very first section, and the second one is breaking those two pieces apart. Now again, why do they do that? Not sure. So the first thing that they would talk about is, hey, we could take this and we could translate it 1, 2, 3, 4, 5 spaces to the right. So translate 5 to the right. That would be your first step. And then the second step would be to go 1, 2, 3, 4, 5, 6. We would then, the second step would be translate 6 down. Okay? So that's what they're saying is, first thing you do is this, second thing you do is this. This is the same exact thing that in one motion, you could basically translate it 5 right and 6 down in one move. Why they're breaking it up into two pieces, not quite sure. So a translation, and we'll learn this about slide 3 here, a translation followed by a translation, in essence, creates a translation. All right? Take a look at DEF here being translated to D prime, E prime, F prime. We would basically say, hey, we're going to translate this, 2 steps up, translate 2 up, and then you could say that we're going to translate it 1, 2, 3, 4, translate 4 left. So something to that effect is what you're looking for. Again, this being multiple choice in a lot of cases is going to make it pretty easy. So obviously we've got 4 left, 2 up. That should be letter B, should be your correct answer. And in fact, it is. All right. As I said, the third slide here simply tells you a translation followed by a translation simply produces a translation. So this is their whole point right here. Translation followed by a translation is equivalent to a translation. Again, not quite sure why they're breaking that up. You can see what they're saying on the far left screen is they're breaking it into two pieces. If you do a single translation, they're doing it in one step, they claim. All right, so that part of it should be pretty easy. That's probably going to represent, you know, about 1/3, 1/4 of your work for this particular time frame. I'm going to freeze it right there so I can prepare for section or for part. Okay, we're back here with part 2 on 23.4, and it wants us to describe a sequence of rigid motions that maps A, B, C to A prime, B prime, C prime, D prime. I think we're going to let those guys show you. They are going to be able to handle this in about a minute, which is probably faster than I could roll through it. So here we go with their description on that.
Method 1, use 2 reflections. First, reflect A, B, C, D across the y-axis. Then reflect the image across the x-axis. A reflection across the y-axis followed by a reflection across the x-axis maps A, B, C, D to A prime, B prime, C prime, D prime. Method 2. Use a single rotation. A single rotation of 180 degrees about the origin maps A, B, C, D to A prime, B prime, C prime, D prime.
Okay, there you go. Now, one of the things they're going to tell you in slide 3 then is if I do a reflection over the x-axis followed by a reflection over the y-axis or vice versa, what you're in essence getting is something that's the same as a single rotation of 180 degrees around the origin. So keep that in mind if you would, please. Take a look at the next slide. And on the next slide, we've got a square. We've got JKLM. It's congruent to J prime, K prime, L prime. Now again, one of the things I would probably tend to do, and you're going to get a lot of this on the homework, is I would take a look at these 4 choices and I'd try to maybe eliminate the choices that you have, all right? So if I take a look at C, for example, rotate 180 degrees around the origin and then reflect across the x-axis. If I did that, would that work? If I look at B, translate 180 degrees or 2 units up and rotate it about the origin, so on and so forth, okay? So let's take a look at A. Translate 4 units right and 4 units up. 4 units right and 4 units up. So if I translate this 4 units to the right, 1, 2, 3, 4, and then 4 units up, 1, 2, 3, 4, that puts M, for example, in this position. That would be, so if that's the case, and I'm going to reflect it across the x-axis, which is this cat right here, that means M is going to be 3 units, I'm sorry, away from the x-axis, and obviously you don't have M 3 units away from the x-axis. So I think we can eliminate A as our choice. All right, let's look at B. I take a look at B, translate 2 units up, rotate 180 degrees. So if I translate this 2 units up, 1, 2, that puts M right here. And if M is right there, I'm then going to rotate it 180 degrees around the origin. If this is the origin, I rotate it 180 degrees. That's going to put M prime right there. We may be in business. That means that L would be located right here. And if L is located right here, and I go 180 degrees, does that end up in that particular spot? Yes, it does. What about letter K? 1, 2 would be right here. So letter K, if I only translated 2 units up, is going to be located right here, and therefore it's not going to fall into the same spot. If I go 180 degrees, it's going to find itself right up in that zone right there. So that means B is out. Taking a look at rotate 180 degrees around the origin and reflect across the x-axis. So if I go 180 degrees, that puts M right here. That puts what? J right here. So let's just, that puts, I was like, that's not right, is it? No, that's not right. So if I go M and I rotate it 180 degrees around here, it's got to stay the same distance. So yeah, that's M. All right, continue on here. If I do rotate M around the origin, and it's going to end up in that spot right there. If I rotate it 180 degrees, that means J is going to actually end up here. Okay, and so if I reflect that then across the x-axis, then J is going to end up on this line right here. All right, and so obviously that's not going to work because J's got to be over in this particular spot right here at what, 3, -1. So that's not going to work. We are going to assume that D is going to be our answer. translate 4 units to the right. If I translate this 4 units to the right, 1, 2, 3, 4, this would be M. 1, 2, 3, 4 for L would be here. That would mean K. 1, 2, 3, 4 is going to be right here. And that would mean that J is located right here. And then I'm going to rotate it 90 degrees about -2, -2. Note that this is the center of the square. And so if I rotate that 90 degrees, then J goes to here, M goes to here, L goes to here, and K goes to here. So the final answer there should be letter D. All right? Again, very difficult to look at. Some of them are going to be easy to throw out, some of them not so much. So again, I would make sure that when you get a sequence of motions that are made different, like a translation in this case and a rotation, I would make sure that you hesitate in order to try to get those answers right the first time through and completely explain it, understand it. All right, I'll take a pause right here until we get to part 3. Okay, we're back here with part 3. We're looking at this trapezoid. A lot of information on this slide. If I give you trapezoid ABCD and I tell you that it's congruent to trapezoid EFGH, here's a lot of little clues that you need to pay attention to. If I'm talking about line segments, take a look at the first 2 letters in this one and the first 2 letters in this one. This means that line segment AB and line segment EF are the same exact length, okay? And so you can, where the position of these letters is going to be important. If I take a look, for example, at line segment BC and line segment FG, then I'm saying, hey, guess what? These 2 line segments are what they call corresponding. And when they say they're corresponding in this case, they are congruent to each other. This could also be true of the angles. So if I took a look, for example, at the 3rd letter, all right, in each situation. And so the 3rd letter in this situation is angle C versus angle G. Angle C, located right here, has to be congruent to angle G, located right here. And we know this again because of the positioning of the letters. So this statement is really important to you in terms of finding corresponding parts. Same thing could also be true if I talk about parallel lines. Obviously, you see that AB, line segment AB, is parallel to line segment CD. And so this would tell you then that those segments are still going to be parallel to each other. If I translate, or if I shouldn't say translate, if I transform the figure and say it's a congruent figure, all right? All right, so the next one is going to be the tough one. Okay, slide 2 is going to be the nasty one, and this is the one that, you know, I challenge you to take a look at. You have to basically look at triangle JAR, and is it congruent to triangle LID? And in order to understand how to do this, what you're going to have to do is go back into the previous part and say, hey, can I use rigid motions in order to create, or in order to put this figure right on top of that figure? So if you could, again, the easiest thing to do would be actually to cut these out on a piece of paper, and if one lands right on top of the other one, boom, you got your answer. Unfortunately, in this scenario, we don't have that option. So we have to look for 2 things that we can do to line things up. Now, the first thing that I pay attention to is, look, just like we talked about in the previous slide, AR, line segment AR has to be congruent with line segment ID, if this is the case. And I'm just choosing these last 2 letters here. So I'm going to take a look at AR. And if I take a look at AR, I'm going to, and again, this is, I don't know if this is how you would describe this, how you see this necessarily, but some people are going to be a lot more visual than others. I'm going to actually reflect that across the x-axis. And when I reflect that across the x-axis, that means R prime is going to be located right here. It means that A prime is going to be located 3 apart from here, so A prime is located here. And that means that J is going to be located 5 spots away, so J is going to be located at this point. All right, so this will be J prime down here. When I connect those dots, I get this figure. Now, the reason I looked at it this way is I thought that if I did reflect that across the x-axis, potentially what I'm creating here is I'm creating parallel lines. And so if I take a look at this A prime, R prime, and I take a look at this, what, D, I guess it'd be D, what, DI or ID, I see that these lines are going to be parallel. And so when those lines are going to be parallel, my next move is I'm going to be able to take this R and translate it one up, and then followed by translating it 1, 2, 3, 4 to the right. And so when I do that, what I'm going to get is this point is now going to be on that spot. So R prime is going to be on that spot, which originally was R. It means that I'm going to go up 1 over 4, 1, 2, 3, 4, and boom, that means A prime is located right there. And that means that J, if I go up 1 and over 4, 1, 2, 3, 4, I'm right on top of that. So in other words, what I'm saying here is I found rigid motions, two rigid motions, a reflection across the x-axis followed by a translation of up 1, right 4 in order to get JAR over 2 lay right on LID, therefore making those or proving to you that those are congruent. So that'll be the tough stuff that you're going to be into. And again, I got to believe there's, and again, that might not be the only way. You could have actually, in fact, if you look at what they said, they did it a little bit different than I did. I think they worked with angle or triangle LID. They first moved it up. I think they moved it up 1 and the left 4, 2, 3, 4. And so they found a different way to do it. So if you find a different way to get it there, fine. All right. Please make sure you don't just guess on it. Make sure you have some logic behind it. Again, this is something that I would expect to talk about Friday morning when we have our Zoom time, and probably go through a few examples with actual graph paper in tow. All right. Last slide here. Which two triangles are congruent? Obviously, our choices were the following. One thing I'd pay attention to is a lot of ABCs there, and one of the things that we should be able to look at is ABC, that is a right angle. So we're looking for a triangle that has a right angle in it, and if you look carefully, I believe that this triangle right here does not have a right angle. It looks like GHI does, and it looks like obviously KLJ does. The other thing that we might be looking for, and again, this is a little easier, I think, than the previous slide. The other thing we might be looking for is, hey, take a look at this, and to get from one point to another, whereas this line for sure you could say is 2 followed by 3. You don't have anything in A, B, C, or GHI that allows you to do that, okay? So this tells me that my choice is probably these two cats right here. Even though all 3 of these are right angles, this one has a length of 2, this one has a length of 3, ABC does not have that, GHI does not have that either. All right? Questions on that? Again, that's something that we'll probably discuss. Obviously, you could go back to that whole rigid motion thing in order to back that up, the ABC triangle going to GHI triangle. All right, I'm going to leave you with that. Good luck with everything. Please, if you have problems with this today, feel free to email me. Here is your piece for today. Okay, should be that cat right there. All right, that cat right there. So that's your code word for today. All right, thank you very much, and have a great day.